I came across an interesting question that I wanted to share with you. Suppose you start with a subset of a Euclidean space that is rectifiably connected. That means between every pair of points in that set, there is some curve within the set X with finite length. And this length is in terms of taking partitions and taking supremum of summation of the successive distances. Now, this allows to define a new metric on X. So for X in X and Y in X, define distance of X and Y to be infimum of length of gamma, where gamma joins X to Y. Because of the assumption that at least one finite length curve exists, this becomes a well-defined real number that is also non-negative. It's clearly a symmetric definition. dyx should be equal to dxy, and easily you can verify the triangle inequality. So the exercise, if we can call it an exercise, is that prove X with D is a metric space. So this isn't the question that I was talking about. My question is as follows. Question. Suppose this X with the ambient Euclidean distance, just as a subset of Rn, is compact. Is xd then compact? So either prove this or provide a counterexample. Let me explain a few details here. One of them was, if you take the Koch snowflake, then this is an example of a connected set that is not rectifiably connected. So we're not looking at such examples. And it explains the difference between being connected and rectifiably connected. This is even path connected, so you have continuous path, but you don't have any path that have finite length. So snowflake is not one of the examples that we consider, and obviously disjoint sets will not be allowed. A positive example is if you have sphere in Rn. So that counts. Even in example of S1 lying in R2, we do have this situation. In this case, the distance between antipodal points x and y will be equal to pi, because the shortest path you can travel is one of the half circles and not this ambient distance. And in this case, obviously x with this d is compact in this example. But my question is, will it always be compact in general? It's a very nice exercise, so hopefully you will have some ideas to put in the comments, and I'm looking forward to reading them.